Now, a massive volcanic eruption in Iceland last year emitted 3 times more toxic gas than European industry. The Bárðarbunga volcano spewed out 120,000 tonnes of sulphur dioxide gas, which can cause respiratory problems. Well, Dr John Stevenson of Edinburgh University's School of Geosciences was involved in the research, which it's hoped will improve understanding of how such events affect air quality in the UK.
This was a project to see if it was possible to measure the sulphur dioxide gas that was coming out from the volcano from the eruption. So it was the biggest eruption in Iceland for over 200 years, but people haven't really heard of it. It didn't really make the news because the eruption was mainly producing lava and it wasn't producing much ash. And it's the ash that would stop the airplanes in Eyjafjallajökull and stuff. But in this case, we were just producing lava, but also lots and lots of gas, in particular sulphur dioxide, which can cause acid rain, which leads to environmental damage, and also the high concentrations in the air can cause lung problems and breathing difficulties, especially in people with asthma. So it's important to understand how much was being produced.
Can, pollution caused as far away as Iceland actually be causing health problems here in the UK?
Yes, so this was what we wanted to find out, and in particular because of a historical context, which was in 1783, there was a much bigger eruption called the Laki eruption, and it was a similar eruption to this in that it was a fissure eruption, a big crack opened in the ground and lava came spraying out, but it came out 10 times quicker than in this Bárðarbunga eruption. And it seems like in 1783, there were a lot of extra deaths in the UK around that time. Also, there was problems with this haze that was in the air all through the summer and lots of pollution. The visibility was really bad. And so a recent study by Schmidt, who was the lead author on this paper as well, she found that if you ran through models of what the pollution might do to people and you had Laki again, they expected that 100,000 extra people would be killed by the pollution from there. So that was the context that they were looking for when this Bárðarbunga eruption began. And the eruption came out pretty powerful. It was putting out over 200 cubic meters per second of lava, which is equivalent to the discharge of the River Tay, basically. So there was potential that it was maybe going to get here. As it turned out, the air quality in Scotland and Ireland was affected, and even it was detected as far away as Finland. But the levels weren't to a degree that they would have caused harm, and it was only up for a few hours. So in this case, it didn't happen. But because of this past history, then it was really important to understand how the gas was getting here in case it did turn out to be that big.
And so was it just luck then, I guess, that the gas didn't come here as much as it might have? Because, when you compare what it was emitting in terms of, Europe's industrial output of these gases, it's massive.
Yes, so that's it. So on average, over the duration of the eruption began at the end of August and ran last year and ran all the way through till February this year. And if you average it out over the whole eruption, the volcano produced 3 times as much sulphur dioxide as all of Europe's industry all put together. But actually, the eruption began really powerful and then kind of fizzled out. So if you look at the beginning, over the first few weeks, it was actually producing 8 or 9 times as much sulphur dioxide every day as all of Europe's industry put together. So it was a massive amount. And again, this could have been causing potential damage, acid rain and things like that. But a thing that's funny when you put it in context with the European industry is European industry has actually been cutting back its sulphur dioxide a lot. So in the 70s and 80s, people realized the damage that industrial sulphur dioxide was causing. For example, trees dying across Scandinavia because of the acid pollution. And so they brought in rules to limit industrial sulphur dioxide, and it's been falling down since then. So the volcano was producing up to 120,000 tons per day. In 1990, it was 72,000 from man-made things.
It's ironic, isn't it, that a natural disaster like that can do much more than, the European industry, and despite all these efforts to cut back.
Yes. Prior to these rules, when European industry was producing 72,000 tons per day, this was causing all of the acid rain. But then European industries managed to cut back since then over the last 20 years. But still, a volcano can come out and can kick all this stuff out so quickly. So it really shows you the power of what the Earth can do relative to all of humans in a whole continent put together.
So how might you use this information in future then?
This information's useful because if the concentrations get really high, then you might need to take some precautions. So for example, in Iceland, which was much closer to the volcano, when the concentrations got really high, they essentially had to impose a curfew and people were told to stay in their houses and outdoor sporting events were cancelled and all of these kind of things. The modelling results and the satellite results have shown that the gas takes between 12 and 48 hours to get from Iceland to the UK. And by comparing the measurements that we made this time with the observations, then it allows improvement in the models and in the monitoring, which means if we have another eruption in the future, we'll be able to make better predictions of when the gas is going to come. And it's obviously a lot more useful to be told, oh, you're going to have gas and asthmatics might need to stay in tomorrow afternoon than it is to be told you need to stay in right now. So it will help people with their planning.
Dr. John